So you are welcome to this masterclass, which is hosted by the University of Rwanda. The lecturer is Dr. Masabo, Emmanuel. He has been helped by Dr. Christine. This is she's around, I don't know if you can see her. Remember her from Uppsala University. And myself, I'm Dennis Danuza. So Masabo is a staff from University of Rwanda, and at the same time also is lecturer. Now today, he is offering this masterclass, which will take maximum 2 hours, but can be even less, depending on the audience questions. So the topic is application of AI in cybersecurity. So Masabo is at the same time also, as he talked himself when he started by giving this lecture note, we give him like a before giving this masterclass, we'll talk about himself in like 1 minute. We are here with a student from University of Rwanda in the Center of Different Studies. We are also having some more in Rwanda, but from Ines Ruhengeri. Can you hear us from Ines Ruhengeri? Dr. Habimana. Dr. Habimana Theodore, can you hear us? But he just said that he's connected. Maybe they confirm later. So
okay, I think they are using the chat box because that's the allowance for participants. So chat box.
But they want to be allowed.
They're not allowed to speak in the webinar.
Oh, so they can hear, but
yeah, they can hear. If they have issue, they can chat.
Okay.
Yeah.
So thank you very much. Let us give the floor to Dr. Emmanuel, and then we start by a brief introduction for himself, and then we are here with students. After this, you will be given a floor for asking questions, and even others from online, they will ask for questions. The student, we are here with the online student also from Uppsala University, from Sweden. We are also with the student from Makerere University from Uganda. We are also with students from Ethiopia, Masabo University. They are also with us online. There are also students from Senelubush. So all are online, and also some from Nigeria. So this is called Masterclass. So without taking long, let us give the floor to the lecture of today. And then Dr. Masabo, go ahead, please, but we start by your short introduction. Thank you very much.
Thank you, Professor Dennis. I want to ensure that people in the audience can hear me. Here I'm with some students and other participants, but are other people able to hear me?
Yes, thank you.
Okay, thank you so much. It's a pleasure for me to have this opportunity to present something in this masterclass. I chose to present something related to AI and cybersecurity. My name is Emmanuel Masabo, as already mentioned by Professor Dennis. I am a lecturer in the University of Rwanda. I am also working in data science as the head of PhD students studies. My research interests include data science, cybersecurity, software engineering, and IoT. I am happy to take this opportunity now without taking too much time. We're going to go through this talk. It is at the general level, I can say like that, but we try to say, I think we have the audience, which is from different backgrounds, and we try to keep it to the lower level possible. So application of AI in cybersecurity. So we can start with what is AI? Everyone knows AI, artificial intelligence. And then we can also try to answer the question, what is cybersecurity? So cybersecurity is a practice for protection. It means it is a practice for protecting systems, networks, and programs from digital attacks. So these kind of attacks can be, the attacks can be sorry for the system. I have an issue with the system. Okay, the types of attacks can attack the system with the aim of accessing or changing the system, destroying the sensitive information, or stealing some money from people, using some ransomware, or interrupting some businesses processes or some usual activities of people. Yeah. So importance of cybersecurity in digital age. Cybersecurity helps in protecting sensitive data, because that is what you saw that these malware or these viruses can do. They can destroy or steal some information. So cybersecurity will help to protect these sensitive data. It will help prevent some disruption of data or maybe activity disruption or functionality. So it will allow the smooth functionality of the systems, and it will also help to mitigate the financial losses. That is some of the things that cybersecurity can contribute in this digital age. So when we talk about cybersecurity, we talked about the threats or some attacks or threats or malware. They have different names, okay? But generally, we can say malware. Now, this malware are as we said, are these attacks which attack the system with the aim of destroying or stealing or maybe doing some other harm to the system. So now what is a malware? I want to see. Okay, what is a malware? As I said, there are different types of malware which have the aim of destroying the system or are doing different unwanted activities in the system. Some of them are viruses, adware, rootkits, ransomware. I'm going to briefly explain this one by one, as you see. So these are the types of malware and many others which are not mentioned here. The virus is an attack, or it's a malware which can hide itself. Okay, it can make copies of itself. It can be transported through some devices, some USB devices, and so on. The ransomware is also a type of malware which locks the PC screen. It requires for some fees. I think we've heard of situations where, like WannaCry, where they block the system functionality and they request for some ransom or some fees so that they can unblock your system and you can have access to your data. But the Trojan horse is also a type of malware which disguises itself as a benign means as a normal software, but when you, for example, you install it, maybe it's something you are downloading, you think it is genuine, you install it. When you install it, it is going to start attacking your system from the background. That is what you call Trojan horse. The rootkit, these are the other malware which hides their services from being visible in the list of system running processes. You know, when you are, for example, on a Windows operating systems, when you want to see the systems which are running, you can see a list of systems there. You can even kill some of them. But for the rootkit, sometimes they hide themselves from the list of visible running processes. So it's hard to know if it is there. The backdoor is another type of malware which creates hidden processes to allow any access whenever needed in the future. So it will also create some hidden processes, then it will be able to access the system anytime in the future. The hardware, these are the malware which place some unwanted advertisement during the software installation process. So these are the hardware. Sometimes you install and you see the advertisements which unsolicited advertisements. So these are also this comes from the hardware. Then exploits. These are type of the malware which exploit a particular vulnerability on the target system. For example, you have created a software and the software is not protected enough. It has some holes, I can say like that. Now from there, the exploit can enter from there and attack the system. Sometimes you will see when you Microsoft telling, for example, if we found this, send us the report so that we can follow up. It's because maybe there was a vulnerability somewhere and an exploit has exploited that hole and entered the system. Then when you realize some malfunctionality in your system, it's good to report it. Then later, maybe Microsoft can develop some patches. And when they tell you to download some security patches, it's good to download them and install them because sometimes they are there to close those holes where the exploits can enter from. So other types of malware, the keyloggers, this records what you do, whatever you're typing on the screen, they record. So now they might be able to know the passwords and sensitive information. For example, you are paying something on the bank using a credit card. The keyloggers can record what you are typing, then they can use this information later to steal your money or to do another harm to you. The spyware. Now, this one, they still use that information without knowledge of the users, of the system users. There are also other called the potential unwanted program. These are the programs the user might find unwanted. They can be a threat to the system security. There are many others, like worm, which is like a virus also. So now here I show the example of the infection process, how a system can be infected. For example, you see one here, this is the source code. Someone has written a source code for his software. Then the source code can be infected by the malware. So the malware, or maybe the person can put okay, let's say, for example, a virus has been able to have access to your source code. Then the virus, as you see, the source code, the original source code is this one. Now the virus has come and implanted itself here in the main. When you run your software, the virus runs first and goes there, runs from the background. Any problem? You cannot hear me?
All okay, we can hear.
Can you hear me? Can you hear me? Can you hear me?
We can hear you. Can hear you clearly. There was just another participant that wasn't muted. Please continue.
Okay, thank you so much. Yeah, now here I'm saying a virus can implant itself in an existing file, a normal file. Then the virus has implanted itself just after the main here. Then the virus code starts running. After it starts running, your code also proceeds. And you don't know what happened. You run something, you download the program, you run it, and while you run it, the virus starts running in the background. And you see what you want to see, but you don't know what is happening in the background. Then this is what happened. Okay. Now this is the process of C. Now the active, this is the virus active on the system. Okay, and the code itself is running as normal. This report is an old report, but what happens actually in this cybersecurity era, is that there are many malware, but most of the malware which are there are actually not new. They are I can say the mutations of the existing malware. For example, here in this report, they said 97% of malware infections are polymorphic, researchers say, which means a malware can be created, but it can change. When it infects, it changes, then it is hard to detect. If the virus knows it as A and it infects as B, the malware knows A, which knows A, the antivirus which knows A will fail to detect B. But A and B are the same malware which do the same thing. So that is what we call polymorphism. Now, polymorphism is that detect, but cybersecurity with AI and machine learning helps in detecting this kind of malware. So this is the virus. It can change in multiple forms whenever it infects. This is one malware, but changing forms anytime it infects. So you see, it is changing the form. So this is the polymorphism type of the feature of the malware. For example, how is polymorphism achieved? There is a person, maybe the malware creator, who created the backdoor or the malware. Then he puts the malware on the polymorphic generator. He creates the new way of this code so that it can change itself while keeping the same functionality. Then he will check the detection. He will see if the new version of the malware can be detected by the antiviruses. If it cannot be detected by the antiviruses, then he will put it on the download server. So a user here will download something on the internet and doesn't know that he's downloading a malware. The malware will infect the user. Here, the user can be the system, the mobile phone, any other thing else. Then the malware will start running on the system, communicating with the malware, the author of the malware, someone using a control and command server. He can communicate with the malware, he can steal some information, he can steal some money, he can do whatever harm he wants to do, sitting somewhere here, accessing your system through the malware he has already put on your system. If this malware is maybe known by an antivirus, he might create other instances of the malware again. So this is the scenario which happens. Okay, this is an example of how polymorphism can be achieved. This is a simple example. This is the code which do same. It has the same. It can do the same thing, but using through different means. For example, this is the original code. This is what it can do. Now, this is variable naming. If the variable changes here, for example, if you are using what you call hash code, you want to see the hash code of this software. It is compiled as this one. The hash code of this one is different from this one. If the antivirus knows this as the hash code, and it uses the hash code to know this again, it will change because some content has changed. Now, it will fail to detect this, and this will do the harm, while this is already known, will be blocked. So this is how, or some of the ways, the polymorphism can be achieved using some simple programming understanding. Okay, so if you follow this closely, you will see at the end, these codes do the same, okay? Now here we can see 5 ways we are trying to achieve polymorphism. That is what we can see as an example of polymorphism. Now, another thing here, when we do what we do the reverse engineering, when we're trying to analyze the malware to understand how the malware functions, we can see this is one malware. Actually, this is one malware or one virus. Okay, now you see, this is the code, I can say, let me put it in simple terms, maybe the assembly code of this one, opcodes, called the opcodes. Now this one and this one are different, but this is the same malware which has been encrypted with a new key. But what the malware, when it is decrypted, it can do this. This is the one. But it can have multiple representations. So this is polymorphism. That is the reason why you see malware with polymorphism is hard to detect. So now here, cybersecurity plays a big role in making sure that this is possible to be detected. So polymorphism means more attacks. Okay, for example, there were more than 430 million malware attacks in 2015. Different, depending on the some antiviruses, they give different reports. We can, when you go, you can download some reports and see what is happening. But nowadays, there are more reports than multiple reports, more than these attacks, because as we move, these things keep evolving. Okay, malware analysis. Now, we understood what is a malware. We understood how the malware can achieve its intentions with other techniques like polymorphism. Now here, what do we do so that you can be able to detect it, to understand it, and at the end be able to develop some antivirus software? Now remember, we are now trying to focus on the cybersecurity part of it. Trying to be a bit fast. In order to understand the malware, first of all, you do the analysis. When we start with the analysis, we are heading towards the understanding the malware, extracting some features, then be able to understand how it works, and later we can create a software or maybe another tool which can eliminate this malware when it comes next time, because we know how it works, we know how it attacks. Now, in order to know how it works, what do we do? First of all, we do what we call malware analysis. You know, remember, malware is, it might be a software, let us say, for example, an executable file. So if this one is executed, it might attack the system. Now, there are some tools or some techniques which can be used to analyze the malware. Now, the malware analysis is a process of understanding how the malicious intent of suspicious files works. So you go, you dissect the malware, you understand its functionality so that you can create a program to stop it. In order to analyze the malware, there are some techniques. The popular ones are the static analysis and dynamic analysis. For example, you have a malware, it is a virus, you want to understand it. You can do static analysis. Static analysis can be done without executing it. You just use some other tools to understand the malware. For example, you can see the hash, cryptographic hash code of the malware. Then you can understand it. You can also do some what you call disassembly. So it means reverse engineering. You do the reverse engineering to understand how the malware works. When you do the reverse engineering, actually, you see these kind of things. Then from there, if you understand the assembly language, okay, you will be able to understand how the malware achieves its activities. So two types, static analysis and dynamic analysis, are the most popular. With dynamic analysis, you run the malware and you let it infect the system, and you see how it infects the system and what it does to the system. Does it delete some files? Does it try to communicate with another person somewhere on the internet? Does it try to call or to run some DA, dynamic link libraries? So all of those things, you try to understand them, then you'll be able to understand the malicious intent of the malware. Now, most of them are actually, you see, these are the malware analysis techniques. The popular one are dynamic static analysis and dynamic analysis. Others can come in this category of dynamic analysis, where you need to use a controlled environment where you run the malware. Then those are what you call sandboxes. You run the malware in sandbox environment, maybe the virtual machines. Then you put the machine there which can be infected, and you run the malware and you see how the malware attacks. Then from there, you record some patterns and use them to create some anti-malware tool. After you have analyzed the malware, then you can create the detection tools. So to have the detection tools, you do now the malware detection. The malware detection is a set of defensive techniques and technologies required to identify, block, and prevent the harmful effects of the malware. You cannot achieve this without analyzing the malware. So malware analysis is the first step. These are some of the malware detection techniques. Again, I can group them. These are the groups, but most of them, when it started, it was signature based. Signature base, it means, first of all, they use, for example, use it to see the cryptographic hash code of the malware. And they say if the file has this hash code, we know the hash code. Next time we find this file somewhere and we compute the hash code, we see it is exactly the same. We recognize it, then we can eliminate it. So this is the signature base in simple terms. But this one is not effective because it is when there is polymorphism, the hash code changes, and it is not easy to detect it when it has changed. So signature base were the most popular, but not very, very effective, but they have been also very useful. Okay, so let me go to machine learning base, where we find where our cybersecurity will play a big role there. Okay, so sandbox analysis is where now you do using some controlled environment, then you try to detect the malware from there. Cybersecurity countermeasures and evolution of cybersecurity and countermeasures. In 1980s, we started with generation 1 of when cybersecurity started, where we had some viruses affecting PCs through analog means. For example, you have the diskette or the flash disk, and you connect there, it is infected, you transfer the virus to another system if you use the same flash disk. Okay, but the second generation, malware started using internet connectivity to spread systematically. Okay, here there was no internet, now here we have internet. So here the countermeasures, they started using firewalls and intrusion detection systems. Third generation, viruses exploit application vulnerabilities. Okay, now here we use intrusion prevention systems. Fourth generation, larger scale zero-day attacks. It means it's something which can attack, you've never seen it. It finds a vulnerability, it attacks from there, okay, and you've never seen it before. Okay, this came with fourth generation. These are the more complex attacks. Morphing or polymorphing as malicious payload designed to avoid detection. They just change the forms to avoid detection. Now here they use these techniques. Now, fifth generation, where we are now, wide-scale attacks using an array of vectors across industries and countries, some botnets, something like this. So now this one, they require advanced cybersecurity features to play a role here. Now, this is where we use continuous adaptive risk, trust assessment, and so on. So here we are in cybersecurity. Nowadays, some antiviruses started implementing cybersecurity features in their solutions so that they can counterfeit these malwares, which are advanced these days. Overview of different types of AI used in cybersecurity. The techniques used, in AI for machine learning, just the algorithms, I will also show some of them later. But we can use natural language processing, deep learning, and the other algorithms, we can use them to build the models which can be used to detect malware. So understanding the role of artificial intelligence. Now, what will artificial intelligence do? You can see it can help in detecting the threat and prevent it in real time because of the features which I'll see later. Okay, because it uses AI. Okay, you have the models created using AI, which can be used in the real time to understand the patterns and detect the threats and in the real time and prevent them. So it can have the anomaly detection in the network, okay, predictive analytics and analysis. For example, it can see something is wrong, maybe it forecasts that some attack might happen based on what it's seeing in the system and based on also on the knowledge it has. It can have automated instant response. For example, you can automate if something is found like this, automate the action. Okay, behavioral biometrics. Some people can type something on the system, then it can know the keylogs and everything related to biometrics. it can be able to understand them. Then, if it is there is a malicious behavior, it will be able to disable it. Yeah. Okay. Threat intelligence analysis, of course, use some intelligence because it is AI to analyze the threat and know what to do. Okay, or what to recommend. It is used in intrusion detection and prevention systems. Now they are using AI so that they can know in real time what is happening in the system, in the network, and endpoint protection, detect and remediate malware infection on the network. So if there are some devices connected to the network, for example, you have maybe a device come and protect connected in the network, it will be able to know this one is bringing some threats or some malware, then it can detect it. Security analytics, so it can also with AI or cybersecurity enabled in security solutions like antiviruses, you can have some security analytics, which are AI driven. Then with this one, it can also help have compliance with governance and other rules, because there are some organizations which ensure there are some compliance with cybersecurity strategies. Then with AI-enabled solutions, it is possible to ensure compliance with regulatory requirements is possible. Okay, this is what I said. AI-driven detection and prevention techniques, anomaly detection. AI algorithm analyze normal patterns. They analyze normal patterns and behavior within the network system, okay, and flag deviations as potential anomalies. If there are some deviations in the normal working in the system, then AI will be able to flag these deviations, okay, and as potential anomalies, then it can recommend what to do. Behavioral analysis, I said this one. Signature detection. This is very important. You remember when we talk about the signature detection, the earlier antiviruses used the signatures to detect the malware or the viruses, but signatures were not effective. Now, with AI enabled tools, they can detect without using signatures. They just have the models which help them to easily detect the malware. Unlike traditional signature-based approaches, which rely on known patterns of malicious code, AI-driven techniques can detect previously unseen threats by analyzing file attributes, behaviors, and relationships. So they analyze these attributes, the behaviors, the relationships, the other patterns, then they can know this is not okay. This might be a malware. Then based on that, they can take a decision. Okay, so with this AI-driven, they use machine learning, use machine learning models, deep learning, natural language processing, said this. So challenges and opportunities integrating AI into cybersecurity. Opportunities is because you need advanced threat detection, so it's good to use AI or machine learning. If you want to automate the response and remediation, it's good to use AI. If you want to do some predictive analytics in your security systems, you need to use this AI. If you want to do enhanced user authentication, you need to use the AI. Okay, and so on. Then if you want to what you call continuous learning and adaptation, for example, the system is being, the system we are monitoring, there are new malware being loaded there by some hackers, some people with malicious intention. So now with this, the model can continue learning, then adapting to new situations. Then it will be able to eliminate most of the new unknown malware. Yeah, okay. There are some tools here. I discussed some tools used for cybersecurity. Some of them are like duct trace. These are some of the tools which are there, which use AI in their detection processes. Duct trace, silence protect, IBM Q radar, Vector AI, Fire Helix. There are many, actually, these are some of them. For example, this one is Splunk Enterprise. It is used for security information event management. There is user behavior analytics. This one, Exabeam. There is this cloud security, Palo Alto Network Risk Cloud. These are the tools which are using which are AI enabled. Okay. There is this one for email security, proof point email protection. There is another one for deception technology, Artificial networks, instant response orchestration. There is this the BISTO, security operations center optimization. There this one. The details are here, how they use the machine learning to understand, for example, to prevent email-based threats from reaching the end users. So now the email systems use this kind of protection tools to be able to accurately protect their users from receiving malicious emails, because they will be blocked by these tools. This is an example. With AI in cybersecurity, we are at the level where with the antiviruses, we call next generation antiviruses. So the next generation antiviruses are the antiviruses which are using AI in their systems to detect the malware. Some of them are CloudStrike Falcon, PT Defender Gravity Zone, Sophos Intercept X, Palo Alto, McAfee MVision Endpoint, Kaspersky Endpoint Security for businesses. These are some of the next generation antivirus solutions. There is another one, there are others, for example, semantic endpoint protection, asset endpoint security, so you can download some and use them. Malwarebyte, end protection, Avast Business Antivirus Pro, and so on and so on. Microsoft Defender for endpoint. So these are some of the next generation antiviruses. All of these are now AI enabled. So what happens now? Remember, when we started introducing the malware, we said the malware, for example, if we take the case of an executable file, we need to be able to later develop the security tool to detect this malware. So how can we do that? The first part, as we said, we do the analysis. We dissect the malware. We know the functionalities of the malware. We extract the features, which are the functionalities of the malware. Then, after extracting these kind of features, which show the functionalities of the malware and how it achieves its intent, we can use them to develop the detection tools. Now, because we are talking about the AI model, cybersecurity, machine learning, we will have to develop some models for detecting. Now, if we, from analysis, we extract some features. Now, the features can be for the normal files, benign files, or the malicious files. Now, we have the features for both sides, the threats and the non-threats. Then, when we have this one, we go to the training phase. You know, this is now the normal process. We have a data set, which is now benign and malicious. Then you do the training, you develop a predictive model using the algorithms I showed you, and the others I will also discuss them later. Then after having this one, okay, now you go to the protection phase, where an unknown executable can come, but using your model you created, you will be able to know if the file is either malicious or benign. So it means your model must be a good model so that it can be able to detect. Otherwise, it will have some false positives. So this is another model or another process. It's the same process actually. Now here we are using the neural networks. Okay, we are creating the model using the neural networks. You see, we have the training phase where we have some more files. Okay, the features. then we do this. You are not going to load the model, an executable file into the model immediately. You have to create the model, you have to do some analysis, extract some features, make a data set. From the data set, you do this process here. Now, this is the model, the artificial intelligence, the neural network model, okay, or maybe deep learning, for example. Then you do some knowledge distillation, okay, from here, and you can use it. Again, you can do the training again. So this is actually, I got it from Kaspersky. This is the Kaspersky, the way they develop their models in the Kaspersky antivirus. So this is the process. Then you see like they're doing like a two-phase where they generate some features, again, using that neural network or that model they created, they can again extract other features again using the model. Then they will be able now to do the training again, and they'll be able to generate then a model which will be used to at the end by the end user, or maybe at the end product, to detect the malicious or malware. So now this is still Kaspersky, okay, from Kaspersky, this one. Okay, you can see there is an executable file. You extract some features. I didn't show how to extract features because it is maybe beyond the scope of this lecture, but it is, you can do the reverse engineering. You can do what you call sandboxing. We remember malware analysis is where we extract the features. We can do what you call static analysis or dynamic analysis. Okay, dynamic analysis, you can use the sandboxing, means the controlled environment. Then we run the malware, we see what it does, we record this information. You can even have a log file, and this log file, you can use it as features. Then maybe we can use maybe natural language processing to understand this log file and develop maybe a natural language processing model, which can be used later, embedded later in the tool to detect the malware later. So this is the process. Actually, it's similar to what we described here above. So machine learning, deep learning, the popular algorithms used in cybersecurity. It's not very okay. These are some of the decision tree, support vector machine, knife bands, artificial intelligence, K-means. I think these are familiar to some of us. Also, here there is a paper. I didn't put this in this PDF because it is too big. These are some of the machine learning models used for detecting, building the models to detect. You can see knife-based, artificial neural network, and so on. All of these. Okay. You can see these are they are not new to us. One thing I want to show here. This is a review paper, and you can see some of the data sets which have been used to build these models, and these were the results. But some of the data set, you can download this data set and use them yourself in your research as a researcher in cybersecurity. This is a data set. This is knowledge discovery 99. So all of these are the data sets. Okay. Now this customized means someone maybe downloaded the files and he created his own data set and so on. So all of these are the data sets. You can download them and use in your research. Okay, this one is very popular, KDD, okay, because it is also there some challenges run on this data set. It keeps being updated, adding a lot of information. Maybe some people are doing IoT cybersecurity, they can use this KDD because they have a lot of IoT cases. Now you can be able to develop IoT models for detecting some IoT issues in the IoT ecosystem. Okay, so these are the data sets and these are the models. I can share this paper. You can understand it better. Other sources of data sets where you can find some data sets for malware, you can go to VirusTotal. This VirusTotal, when you go virustotal.com, this is an antivirus, this is a website. You can go there. When you go there, you will find some, you can request some data. Sometimes they might ask you to pay some money, depending on, or maybe if you say for for education purposes, they might not ask some money, but getting the viruses for practice or for research, sometimes you need, if you cannot get the good virus you want, you need to pay for the viruses, okay? It's funny, but it's true. You pay for the viruses so that you can use them in your research. There is another one, malware genome project. You can find some viruses here or some malware for research. Microsoft malware classification challenge dataset. This one is on Cargo. You can go to Cargo, you download this one, and also understand some. There are so many problems which happen in Microsoft now. They create a dataset. There is even some challenges going on a Cargo. So you can download it, this one, and do some models. Okay, you can go to Contagio malware dump, malware attribute enumeration and characterization, Cargo, GitHub. There's what we call malware zoo. It is on GitHub. It is free. It has some malware, but don't download them on your computer straight. Be careful because you might infect your computer. So you have to be very careful when you want to download this. Okay. There is a National Software Reference Library, research papers and conferences. When you read the research paper, for example, I was reading the research paper here. There are I got information about some data set. Now from there, I can go and find this data set. I can go to this paper and they tell me how they got it. Then you can even write the author of the paper and get information from him. Okay, there are some security companies like Kaspersky. You can request some malware, Semantic, McAfee, and so on. Okay, this is it. Now going to the end, after you have developed your model, your model is there and your tool is here. So how will you be able to use this model in that tool? So you can go to you can go straight here. You can go to the development or to the deployment of the model or embedding the model into the tool. Okay, when you have your tool, for example, you can do, these are some of the steps, integration of the model into an antivirus software. Okay, you can define the architecture of how you integrate your model into the antivirus. For example, you can select appropriate programming languages or frameworks to use, okay? Then you can develop an API, the API which help your application to connect to the model and understand and now facilitate the communication between the AI model and other components of the antivirus software. So you can use RESTful APIs, okay, to expose the functionality of the model, AI model, allowing the scanning engine to request predictions for suspicious files and receive responses indicating whether they are malicious or benign. Okay, after that, you can package the model and deployment. Okay, you can package the model into a deployable format compatible with antivirus software. Okay, this can include, maybe you can use Docker, okay, or you can create standalone executable files. You can maybe deploy your model as a microservice and so on. So after this, you can test. After testing, then maybe you can check the performance of your model, or you can do some fine tuning of the parameters and so on. Then later, you will be focusing on continuous integration. Your model, if your model is okay, is good enough, it can keep learning for the new things as we saw. Now your model or your antivirus will be able to keep updated and to keep to be sharp and know how to detect new unknown malware. Yeah, so I think these are the challenges for cybersecurity in AI. Be some bias, maybe in the data set, some data quality and the quantity, regulatory compliance, skill and the training. Cybersecurity has it needs some extensive training. So skill gap is one of the challenges. Sorry. Okay, I think to summarize, I'm at the end. In cybersecurity, if we have a malware, first of all, have a malware, do the malware analysis to extract some features, some functionalities of the malware, have a data set from there. Now from the data set, build the model, you choose the algorithms to use. Then you have your tool, you now deploy your model into the tool. So this is the end of the presentation. Thank you for following.
Thank you very much. Maybe let's have like 2 minutes and let the lecturer relax a little bit and then ask questions. 2 minutes for relaxing a little bit. Let the lecturer have his coffee and then we come back in 2 minutes.
Okay. The
If there is any question from the chat, we thank the lecturer really has given us the lecturer. So I can see online we are 92 people online, but the attendance may be higher than that because, for example, in this class we are more than 20 or 25. So and the only one is connected. So even also in Hungary, there are more than 30. So the attendance may be higher than this. I think the attendance was good. So let's go to the questions. We start from this class and then we go to online. Is there any question from this class? The physical class. Yeah, yes, please. Go ahead.
Thank you so much for the insightful presentation. I have 2 questions. The first one relates to compliance and governance. This is related to mitigation of the cyber attacks. How far have we gone, or what are the gaps, maybe in the context of the developing world, as far as regulation and compliance is concerned? And the second one is related to the solutions. We find that in present times, most of us are using the lightweight devices, which are limited as far as resources are concerned. Are there solutions that are tailor-made for our small and resource-constrained devices? Thank you.
Okay, maybe we'll let him answer. Are you writing the questions?
I'm writing.
Do you mind if we get like 3 questions from the room and then we respond?
It's okay.
Okay, another question. A participant will let the lecturer respond to 3 or 4 questions at a time, then we go for online. Another question from the room? So there's no any other question, then lecturer, please, can you respond to those questions?
Thank you so much.
Members who are online, you can also contribute, no problem.
Yeah, thank you so much. Yeah, you said it actually. I was going to ask some experts in the field who are on board to also help in answering. Yeah, but for compliance, that was the question. How far are we with compliance? What I know is that the governments and institutions And so they are establishing some cybersecurity strategies. And also there are some standards which are there, international standards for cybersecurity, which have some compliance rules and requirements you have to follow. So it means it is there, but if you are, for example, developing an antivirus, it's good you comply with the standards. But make sure you follow the standards. The standards are there. But maybe you can understand this better if you go into this business of creating these tools. Then you see the standards and you have to follow the standards. So to be brief, standards are there, national-wise and internationally, they must be followed for the product to be acceptable. The second one was, are there some solutions for the lightweight devices? Yeah, you can see there are many tools for phones. They're there. What you need to know is to search on the internet, because I know most of us, we use phones. We don't put some security tools. We think that there are no phones, there are no malware in phones. Actually, when you go to these data sets I showed you, you will see most of many malware for Android. For example, if you go to malware zoo on GitHub, you find some malware for Android, and also many other things, even for on virus total. There are so many, which means there are many viruses which attack Android systems. So there are also some antivirus for Android. What you have to do is to be active and try to find which ones can work for you. Thanks.
Thank you. Any contribution from online? Online contribution? Raise your hand if you want to contribute. I want to contribute. Just the two questions.
You mean the question?
Thank you for your presentation. The sandbox you mentioned.
Oh, the sandbox. For example, the most popular one is the CoRE sandbox. This one is an emulated environment. You can, for example, maybe have you install it, then you have, for example, like a virtual machine, and then from there, you can infect some machines which are installed in this CoRE environment, and then you do your malware analysis safely from there. So the CoRE analysis is sandbox. You can find it from there. Another question? I believe currently AI is not.
Okay, just feeling that the talk will be on our YouTube channel by tomorrow. So tomorrow you can go to the YouTube and then check the talk.
Okay, there are some questions for, I think all of us, if you ask a question and you have an idea about it, you can also help me answer this one. I believe currently AI is not the best solution to handle cyber attacks. The bugs in the cognitive code and training models can easily be manipulated. What is your view on that? Yes, what I can say, there is what we call adversarial AI. Of course, whenever there is an antivirus solution, these people are also very smart. I mean, these authors of malwares, they are very smart. They also create some other tools. There are even some tools which try to fool the AI-enabled antiviruses. So it means now, with the help of continuous learning of your model enabled for your systems, you will be able to at least to understand some new parameters, new features, new patterns of the already known malware, and be able to counterfeit that with also other new techniques. It depends on how you will try to study the problem and which techniques we are trying to use to further understand it and counterfeit it. But it will remain the problem because those malware authors are smart, the antivirus authors are smart, so it is like a game. You do this, I try to defeat it, you do, again, it is a process like that, but I think, I believe at least the antiviruses with AI enabled are trying their best, although they cannot be 100%. Thank you.
I think, please, those who are experts can provide also some input, not only asking questions. There's one who raised his hand. Of course, because I shared many times the link, so I'm appearing many times also. So if you are the one who raised the hand, please go ahead.
Dennis Ndanguza.
Yeah. I shared the link, so the one who raised his hand in my name, please go ahead. Oh, maybe he can't talk. If you can give.
Can I come in?
Yes, please go ahead.
Thank you. Reading in the chat, I have realized that someone asked a question like this. There's always a myth that antiviruses are created by companies after they have created the virus. And this
please say your name and where you are.
Oh, okay. I'm Charles, working in the. I think you can now see me on the screen. I'm Charles, yes. Working at the University of Rwanda, the African Center of Excellence in Data Science. But reading in the chat, a question came to my mind about the business part of viruses and antiviruses. You know, IT people, though they have been trained to help people, to help the communities and the world at large, but the idea of benefit and especially self-benefit, financial benefit, you create a system and you create a virus which will need an antivirus that you will put on the market. And so you keep controlling the users of the system you have created in order to gain money. Dr. Emmanuel, how do the cybersecurity companies manage this issue of business in cybersecurity?
Thank you so much. For some of the questions, maybe we need some facts, some research. But what I can say is true, someone who creates an antivirus can also create a virus. Because in order to create an antivirus, following the steps I told you, you do the malware analysis, you go deeper with the dissection of the malware, then you understand the functionality. So it means from the basic, you understand the functions from the roots. You are also able to do the same, or maybe you can change it and you have the same, exactly the same virus, so maybe add other functionalities, so it's possible. I don't have figures for that, but I heard about it, and it's possible that someone, because he has the capabilities, he can create an antivirus and not a virus, then create a malware tool to remove it. Then when you maybe you download something on the internet, you are infected. This person who infected you can create another tool. It tells you to download this. Maybe you pay for that to remove this. It's possible. Although I don't have maybe straight figures to do this, but it's possible because he has both skills. Thank you.
Thank you. I can see Chilongo. Sorry if I pronounce badly your name, but you wrote a question in the chat. Can you explain it well so that we can understand it? The lecturer can understand it.
This one, I believe?
Yes.
I explained this one. I asked.
Okay. René. Can you hear us? If yes, please express to have your question.
What are the consequences of not having cybersecurity that maybe a majority is not aware of? I'm not.
So if you can hear us, please, Rene. Rene, go ahead. Okay.
Is it cybersecurity skills or cybersecurity knowledge?
So can you get me?
Yes,
yeah, we can hear you.
All right, thank you. So my name is Gitsi Chilongo. I'm from the National Institute for Scientific and Industrial Research.
Can you increase your voice, please? Increase your voice.
One.
Okay. My name is Sinonele
Right, so I believe
my name is Sinonele
it's still in its infancy,
city.
especially when you're looking
Question.
at all those I'm hearing another voice. I don't know if you can still get me.
Go ahead, please.
You can continue, sir.
Okay. Okay. Gaudence Nirere, can you hear us? Gaudence.
Maybe while there, we have some questions in the chat.
Yeah.
Okay, here there's a question. What is the current technique or tool used for detection of threats or malware in order to minimize cyber attacks? What you can see is that there are so many malware tools or maybe antivirus tools which can be used to detect the malware, but not all of them are at the same level of the detection. Some of them might be more smart, others are not at that level. So what you do, you can do the market survey and see which one, if you want to buy, pay for it. Because I know some of the users, they like using open sources or free versions, which are limited. But you can do the market survey to see which one has maybe some good reviews and they use that one. But if you want to know some of them, for example, when you go to VirusTotal, this is VirusTotal. It's maybe where you can start from to find some of the tools which can help you to, for example, okay, the internet is slow. Yeah, while this is loading, I wanted to show there are so many. I also gave some here in this lecture. I gave some of the tools you can find. Yeah, these are the tools. Okay, but when you go to VirusTotal, for example, you see these are the security vendors. Okay, these are the ones. There are some of them which are popular. For example, Avast is known. Any NT-AVR, BT Defender, CloudStrike Falcon. See, I think we mentioned this one. They are using AI. They are AI enabled. He said, okay, Kaspersky. So now, if, for example, you have a file, you are not sure this file, if it is genuine or not. For example, you download something, before executing it, you are not sure if it is safe or not. What you can do, you can upload it to VirusTotal. When you upload to VirusTotal, VirusTotal will contact all of these antiviruses, and it will ask them what they think about this. Some of them will say it is genuine, others will say it is not safe. For example, the file downloaded, the file run here was not safe. You can see this one, 65 antiviruses found this one as malicious out of these out of 70. It means there are 5 of them which failed to detect it. But you can yourself say this one is malicious, because you can see even the percentage. Now from here, I do the market survey. Which one of these can I use? Which one is better? You can do the research from there by yourself. So maybe this is the starting point where you can get some information about the tools. Or you can use ChatGPT, ask ChatGPT. They can also give you some list of the tools, and you also ask ChatGPT more details about the tools. Then you can see. Then you read the paper. You read the papers. There are many ways, but anytime you need to do the research to understand to get more information about what you want. Yeah. Thank you.
Thank you. Any other question? Yes. Thank you for the starting presentation. What can be the process to follow when we want to design a machine learning model that can detect different types of attack? I think you mentioned.
I think this is what I have been actually explaining.
Yeah.
Or
maybe you just want to come.
Okay, to summarize, maybe the process. First of all, must data set to start with. It's possible you can download a data set which has already been cleaned. For example, if you go to Cargo, you download the Microsoft data set. This data set has already been cleaned. All the features have been extracted and all the functionalities. You can download it maybe as a CSV and use it. But if you want to really understand the process and how you can start from the scratch, it's good, for example, you can learn assembly language so that when you download a real malware, an executable file, you can start with assembly language. You dissect the malware, you understand the functionality of the malware from the roots. Then from there, you get some statistical features. For example, if I go to virus total, I click here on the details. What I see here, these are what you call statistical features. We get these features using static analysis. All of these features are informative for someone who wants to develop some AI model. All of these features. But when you use some tools, you will get more information. For example, this virtual size, row size, entropy, MD5. All of these are the features you can use for your data set, for your model. But these are not enough. You need to use the tool, for example, like IDA, okay? IDA Professional. It can help you to dissect the malware and understand more. You need to know what you call assembly language. Then you can go here, for example, now this malware has some behaviors. From here, you can see some behavior of this malware. Okay, maybe it is executing something. For example, it is, let me see. Okay, I cannot see. Okay, it is opening some files. You can follow the malware to see files. Why is it opening these files? Which kind of files is opening? Which kind of files is creating? This malware, does it run? When it starts running, does it delete itself? Does it change the name? You can track all of these things. Okay, when it has written some files, you follow the files. Now, for example, this malware is writing somewhere in the registry. So it is doing it is even deleting some files. All of these are the functionalities of the malware. So you take all of these plus these, okay, all of these, then you create your data set, which is a rich data set. From there, you can now start developing the model using the algorithms you know. But depending on the problem you have, you can use either natural language processing, you can use the deep learning models, you can even use convolutional neural networks. Okay, it depends. It's up to you, but depending on the problem, you always have to read the papers to understand which can work better based on the context of the problem you have. Then from there, when you have the model, as I told you, if you are a good programmer, you can even have your own tool, you develop some other tools using the knowledge you have for programming, then embed your model or maybe create an API. Those are the process. Okay.
Thank you. I think the next question also has been answered. Any other question from one? Raise your hand. Or just provide yourself.
Okay, some review papers I use, yes, I will share them.
Okay. So, in this class, do you have a question?
Think this has intelligence. When they know that maybe someone takes, even them they can make grades, some malicious checks that within the training data set. So how this machine learning model can be adapted? Because I've been following the slide that you have been presenting.
Yeah, excuse me.
Yes, please.
Thank you so much for your wonderful presentation. My name is Mohire from Kenya. Basically, I've been in this area of IT for a while now, and I'm interested in cybersecurity research areas. I really appreciate your presentation. And it's true that to say that basically people create problems to create solutions from the problem they have created to continue earning a living. So we do have such an element in the society where people create viruses or malwares and then end up to create antiviruses to continue earning a living. So they have always to stay afloat. However, reputable companies do not or cannot participate in such a kind of activities. So it is a society where people have to keep abreast with what is happening. And that's why we are seeing viruses coming every other time. And one of the reasons why it is very difficult to detect and even prevent some of these, criminal elements is because they are perpetuated through this technology. Now, my question is, can we use cargo data as data that you can use in your research for our applications? Because that is secondary data. I know the difficulties and the challenges that surrounds getting primary data, but can we use that data as long as we cite it, and that can produce a scientific application or for your study, please?
Your question is understandable. You are asking if we can use it as secondary data. Is it? You just also want to know if the data can be trusted.
Okay, yeah. So let me also finish the question. Then I ask.
Okay, so there's one also started this question in this room. Let him finish.
Speak loudly, maybe for
loudly.
Oh, I was asking, maybe these attackers, there is so much intelligence, more than you can think. So, for my knowledge, maybe he can invent detection through injecting malicious data into the training data set. So, how can machine learning model can be adapted for that new change of So, B of that question is saying, how can we show that the data that we are training are based on the part? How the part of the data that we are training, how comes for its quality? Because I've been just following the presentation, most of the data sets I've been seeing, maybe 2010, 11, 2018, but now we are in 2024. So how this data can be in terms of data?
I think it's between two questions there.
Yeah, thank you. Yeah, maybe starting from the last question, you mentioned two things: the trust of the data you receive and the adaptability of the machine learning model. Yeah, actually here for the trust of the data, as I told you, you might download a data set, which is maybe a CSV. So you must first of all know the source, who developed it, maybe did he maybe publish it, where did he publish, you can have a lot of questions and follow up to see if you can get it. You can get it right. Otherwise, someone can put something and say, this is malicious, this is not malicious, and you use it and you think it is okay, but maybe it is not having good data. But for example, like the data from Microsoft on Chicago, that one you can trust, but it is a CSV. Then when you go to download the real malware, what I told you myself, I think it's better. You start from the root, you download the malware, the real viruses. You use the controlled environment like sandboxes, Kuko sandbox, for example. Then from there, you run them, you see what they do, you follow them, but you need to understand what is happening. There are so many tools to do this. Okay, then from there you create your own data set. You must have a lot of data malware and you run them. It is a consuming work, time-consuming work. It requires skills. But that from there, you can even have your own data set. You can publish that data set, and you can even give it for to others for research purpose. So there are some universities which have some data sets they use in their researches. You refine them. When you read the paper and find the data set they use, you can even request, okay, from those people. They are many people to trust, okay? Then for the adaptability, you remember this is like a last step in this AI-enabled cybersecurity, continuous learning adaptation. So it means in machine learning or AI, we have this continuous learning. So you have to go and read about continuous learning, machine learning, and see how it can be implemented. Then from there, we understand how it can be implemented. This one will help you to understand the new features, new parameters which keep happening. As we said, this will never stop. These people are smart. They will keep doing this so that they can earn some money. You know, the viruses are there for earning money most of the time. Okay, that is what I can say. Now, another person from Kenya asked if cargo data can be trusted. I think it is some of the data set maybe you can just use to get some simple models, but the data set, for example, from Microsoft, it can be trusted. And there you will find, I'm sure you will find some applications out of it. And because of some challenges already on cargo on this, if a person, maybe a team or a person creates good models, maybe he gets an award on cargo. I don't know if you've ever done these challenges on cargo competitions. You create a model which is better than others, then you get a reward. You can even publish about your model. So this can be published and it is acceptable. Thank you.
Thank you. Thank you for the questions and the answer. There's one question which is coming many times. This one, thank you. Are there any machine learning DL method for such use cases like malware detection? I think this question has been answered.
Yeah.
Method has been, okay. And then thank you, Leonard Mutembe, I don't know, you answered the question from Botswana. And then there's the last question, the one which is coming from online. Please contribute. Thank you, Mutembe.
Yeah, okay, please, the audience, can you contribute to these questions? For example, the last question.
Can anyone contribute? Not only the lecturer. There are many different malware attacking systems in real time. I wanted to know, is there any multimodal practices for controlling and managing real-time detection of the malware activities despite depending on the antivirus? It's just asking the early detection.
Yeah.
Early detection.
Maybe...
Anyone from online or from the class? Yeah, we've got some references from online.
Yeah.
Online, can you contribute?
Okay, while some people online can maybe preparing for coming, I can have something to say about this question. Yeah, having an antivirus sometimes might not be also enough because you realize that even one antivirus might not be enough, smart enough to understand or to detect all the malware. There might be other antiviruses which detect some malware which are not known by this one. So it's also another trick thing. But you can also have, for example, in the network, some network sniffing tools like Wireshark, where you keep observing what is happening, or other tools. There are many tools you can use, for example, to understand what is happening in the system. Then this can help you to trigger some malicious intents, malicious activities from there. So having antivirus itself is not enough. Go and do the research and see how you can do the network sniffing. I gave an example of Wireshark, but there are many other tools. I think that is what I can say, but experts on board can also.
Assignments. Question number one is go and do research and see if there is some other early detection method which can prevent the antivirus. Just read it and then see there's some developed models which can do that. Okay? Another question? Yes, please. Hello.
Thank you. My name is David. I want to ask about in cybersecurity, there is a section of open source intelligence. So I want to ask you how application of artificial intelligence is going to be applied to counterfeit or to work as a protection about those open source intelligence, since even if it is a section which we can join, but availability of those information online or in everywhere will have negative impact on our economical or other facts, for example, on the privacy of personality. Thank you.
Thank you.
Also, before going to this question, there are some other contributions. Like Mutembe said that the network can also use firewalls, intrusion detection system with antivirus. Thank you, Leonard. Then another one, my name is Singelele Masizana from Stellenbosch University. I'd like to know about the consequences of not having cybersecurity that maybe the majority is not aware of. So this is a question, and I'll start by the one from this class.
Yeah, so you said the open source intelligence. What can you elaborate more about that? You mean the open source software?
We know that sometimes there are availability of our personal information, but can be available for the institutions or organizations that have ordered to use it. For example, in the banks, they request our usernames, IDs, and other things. But sometimes we meet with the challenges of finding those information publicly. For example, in the last year, I was in a workshop that happened in these countries. They told us in the recent years, there is an attack which have taken the Rwandan IDs and they publish it online as a ransomware attack. So how application of artificial intelligence is going to be used to reduce the problem of availability of those open source intelligence information? Thank you.
Okay, yeah. So I think this question, maybe it depends on the vulnerability or the weakness of the system you are using or you have been using. For example, let me give an example. When you want to buy something online, don't trust any website. Actually, most of the websites which are secure, they have this HTTPS, that S is for security. Okay. But you might have to put your credentials to a website which is not trustable. Then they will steal your information, credit card information, and they will use this information to steal your money. Actually, they can use this information to buy something using your card, and maybe they sell them. That is how they can maybe steal your money. Do you understand? So now, if we have this these antiviruses, for example, AVG or malware bytes, they have the web intelligence. They monitor what is happening on the web. Sometimes there are some suspicious websites. If you receive this information that the website is suspicious, be careful, because it's up to you. You can either disable the antivirus and use it if you want it, or you maybe listen to antivirus and not use it. Okay, so it depends. But again, there is an issue. Sometimes there might be some false positives, which means this appears as a malware or malicious when it is not malicious. So some antiviruses might have also this bias sometimes. So now, again, as a human, you also try to your best way to understand further, maybe using other tools. Maybe you can send that website to VirusTotal, because using VirusTotal, you can take the URL of the website and upload it there and ask them to scan. They will use a lot of antiviruses. They will contact a lot of antivirus engines. Now, those engines will tell you this is genuine or not, and maybe you can trust it. Okay.
Thank you very much. Yes, go ahead, please. Say your name and your location.
There is a contribution here.
Yes, Leonard has contributed. Just say we need to enhance the cybersecurity awareness within our African community in order to protect our systems. Example, in the health sector, online shopping, transportation, bank system, and many more. Really, thank you, Leonard. I think this can be a nice project. So start the concept note of this project and enhancing the cybersecurity awareness in the African communities or African business. So it's going to be a nice project. And then sure we can work with the lecturer and develop the project for further elaboration. So there's one who was online. Can you go ahead, please? So if you know any question from online, if there's no other question, I think we can stop here our lecture today. Another question from the class? Or we just go. We recognize the presence of director of IoT. Please come here for they want to see you. Is the director of the African Center of Excellence in Internet of Things. Just please, can you greet the audience who are following you from? We are having more than 19 participants. Then we also have like more than 6 universities who are following online. That's one word for blessing the class, and then.
Okay, thank you very much for having this seminar happen here. And also, as this is the host, the seminar was hosted by the center. This is where we are. So I hope we had some other seminars coming here. And this is a very good opportunity to share the knowledge in security using AI. And I think we have been able to have other topic in IoT, which the topic actually remains social media, AI. We hope this time also will be hosting other seminars. Thank you very much for the.
Thank you. Thank you. Okay, let us start for the lecturer. Okay, thank you everyone who has attended this masterclass. Thank you, the host. Francesco, are you around? Francesco? Is David around or Kajasa? David, are you around?
He said yes. He said yes.
Yes, okay, thank you very much. Is Francesco around? Francesco?
Can you hear us?
Yes, please, one word before we close.
Good morning. Hi, it's Rena here. Prof. Francesco just came to pop in now to say good morning and thank you very much to everybody attending. Prof. Francesco needed to run for another meeting, but he wanted to welcome and thank you all the participants at this excellent event today. Thank you.
Thank you very much. Okay. Is Kaisa around? Kaisa? So if there's another one from Makerere, is John Mango around? Just one word before we close. Anyone from Makerere University? Yes, you can see. Matthew, thank you. From Ethiopia, Addis Ababa University. Addis Ababa University. Okay. Since this talk will be posted on YouTube and people will follow up. So let us close this masterclass and thank everyone who participated. The host, Stellenbosch University and the Guild, Uppsala University. They are the ones who are our guild in Yarua. So thank you. I really thank the lecturer. Thank Christine for your contribution a lot. Thank also the center for hosting us, and thanks to our student Ines Ruhengeri. Ines, yes, I can see. Thank you very much. And then this to close the session for today, our masterclass. Thank you very much.